Hello, everyone. I'd like to welcome you to the AI in Action virtual meetup. It's our first of 2021. So, Happy New Year to you all. My name is Mark Kelly. I'm Chief Customer Officer at Alldus International. I'm also the founder of AI Ireland, and day to day, I'm an executive search consultant. So, on today's virtual meetup, we have Matt Dancho, CEO of Business Science, and we also have Guglielmo Iozzia. And they're both going to give us a bit of an overview about their journey to data science. And Matt's going to talk about how he came up with developing the courses that he does for business science and some of the consultancy experience he's had in data science, and tell us a little bit more about where the market is going and what's in demand. And Guglielmo is going to share computer vision in the wild and talking about productionization of computer vision models and the reality of what you need to do to make sure that you actually make it into production. And once you're in production, that's where actually the journey really starts to monitoring and refining the work that you do. Before we get started to that, I want to give you a little bit of an overview about Alldus. Alldus is a recruitment company specializing in AI and data science with offices around Europe and the US. We've set up the company to move forward in artificial intelligence, and we wanted to be very, very community driven with the value that we added within to the community. So all the starts for is we're ambitious, we're listeners, we're learners, we're driven, and we're unified, and we're specialists. We've got our main hubs in Brooklyn and in Smithfield in Dublin. And we would have, before COVID, we were hosting a virtual meetup, an in-person meetup in Berlin and Dublin, the first Wednesday of every month. And since then, we've switched that to a virtual meetup the first Wednesday of every month. And in that, we showcase a variety of different topics from natural language processing, computer vision, AI in healthcare, and a variety of different domains as well. You'll soon be seeing the US version of our podcast and virtual meetup series coming very, very soon. To give you a little bit of an overview about the amount of content we've shared since 2018, we've had over 40 plus events, 100 plus speakers, and over 7,000 people have attended either in person or virtually. We have two podcast series that we host. One is called AI in Action, and the second is called AI Mentors. AI in Action, we talk about how you solve a business problem by applying machine learning to it, where companies and guests come on and share what they're looking to do in this area. And AI Mentors, we talk about how to build out a data science team, how to manage research, generate return on investment from it, and really the area that is looking forward to growing in this there. Unlike typical engineering practices, it's quite tricky to actually generate return on investment unless you've got a very good cycle of work that you're doing in that. You can catch these podcasts on any podcast provider that you use, mostly on Apple, iTunes, and aldus.com/podcast is where you'll be able to find it. We have over 210 podcast series currently available now. We're really, really proud to say that we've got over 300 five-star reviews on Google, and we're seen as one of the most trusted recruitment agencies in Europe. And that's been focused on our candidate and client experience. And we want to take that very, very seriously and add a lot of value into the marketplace. We don't sit on our laurels, though. We're constantly looking to try to improve and grow and develop every day. As a recruitment company, you'd expect us to have new positions. Here's an overview about some of the positions that we currently have available. But if you go to aldus.com/jobs, you'll be able to find our latest positions across Europe and North America as well. For more details regarding career advice in terms of landing that next interview or any other advice in terms of where the industry is going, there's loads of different materials under our careers hub. So please feel free to check that out as well on aldus.com too. So our first guest today is Matt Dancho, and Matt is the CEO of Business Science. And I've had the pleasure of knowing Matt for over 2 years now. Matt is going to give us a little bit of his overview about his journey to now, how he built up Business Science, some of the courses that he offers, and later we're going to talk a little bit about the market and some of the appetite for different courses he's doing, the growth in ML ops, DevOps, and Python versus R. We might get into that a little bit of that debate as well. Matt, great to have you on the virtual meetup today.
Thank you so much, Mark. I'm really excited to be on AI in Action. I just can't wait to talk with you. All right. So, what I'm going to be talking about today is how I built this business. And, I'm a big fan of, if you've ever listened to that podcast, How I Built This. So, I wanted to kind of give you a little perspective of my journey to becoming a data scientist, but also how I built my company as well, which is called Business Science. Here's the URL to it. If you want to just Google Business Science, you can find out more about us after. And you'll see here at the front of the screen, obsessed with R. So if you're into the R programming language, or even if you're on the outside looking in and have never heard of R, this will be a good presentation for you if you're interested in learning more about the R programming language. So to get started here, the beginning of my company was it was founded in 2017, but that wasn't the beginning of my data science journey. And really, that's what I want to focus on in this presentation is how I grew as a data scientist and my journey. We all have our own journeys. So my journey actually started in 2013. I used to work for a company that made valves and industrial equipment that went into oil refineries. And what I was kind of thrust into, so my background's in mechanical engineering, and I was managing at the time a team of engineers, mechanical engineers, mainly designers and product specialists. And I got thrust into a new sales management role, which was very weird to me because I knew nothing about sales, but it was a good opportunity for me, and I knew I needed it if I was going to grow with that organization. So one of the things I started to do was to kind of take a step back and see, hey, how can I actually help this organization? It wasn't going to be teaching them how to sell better because I knew nothing about sales. But what I felt that I could do was provide some analytics. I felt that was my superpower. I think everyone has a superpower. Some might be communicating with people. Others might, be really good at doing technical analysis. For me, mine was being able to analyze data. So, and in parallel, I got my MBA, and I was using primarily a tool called Excel, which is what many people get started with. So one of the issues that I quickly ran into as I was thrust into this new role was I was in a situation where I was downloading and connecting to databases, our ERP system, which housed all of our sales data, customer data, many different tables. It was primarily in SQL, and I would connect to it through Excel. And I would constantly get this thing called the Excel blue screen of death, which is basically where your computer shuts down. You can't do anything. And, it was really, really annoying because it would be happening to me like 6 times a day. The best part about it was when I was on conference calls with VPs and the CEO of the company, trying to get my data downloaded 10 minutes, 15 minutes before the meeting. And when that blue screen of death happens at the best possible time, right before our meetings. So it was definitely something I need to address. So that's where the two different languages that came that people primarily use for data science now. That's where this kind of came into my life because I knew that there were some better tools out there for crunching numbers and analyzing data. So this is where we kind of transition into going from Excel to R and Python. And for me, it was just trying to figure out, what worked the best for me, what was going to get the job done. So R or Python was what I was going to test the water with. And I actually first started in Python. And this is kind of what I started learning. So I was learning all sorts of different things like, just programming, how the programming language worked. I was learning objects and data structures, all the ins and outs of the language. So like for loops, how to write if statements, how to do object-oriented programming, handle errors and exceptions, work with the built-in functions and the built that come with Python. And then on top of that, some of the more complex objects like generators, working with decorators, working with the Python standard library. And it was a lot. Especially for a mechanical engineer with no computer science background. And I felt like this, a fish out of water. My background was mechanical engineering. I had a good handle on stats. I was taking my MBA at the time, had a pretty good comfort level with Excel. But when we're talking about going from Excel and maybe some VBA, which is a programming language that works with Excel, to transitioning to a full-blown Python programming language, I felt like it was a lot. So I wanted to, I spent about a month, but eventually I quit. So I got to the point where I was just fed up with it, and I was just like, okay, I wasn't able to make as much progress as I would have liked learning this. So what I did naturally in the office environment, you know, as would happen, one day I had a conversation with a coworker at the water cooler, and I was kind of joking. I was like, "Ha, Excel just crashed my computer again, for the sixth time today." And he was, he was a new graduate that we had hired, and he'd only been working with us for a couple of months. But he actually said, "Well, hey, have you tried out R? It's a I, he said, in his program, he was also a mechanical engineer. A lot of his professors were actually playing around with R, and they liked it a lot. And they said, it's more like stats heavy, stats focus. It's less on the programming side of it. So that kind of was what clued me into the language. But it was still so what ended up happening is naturally, you try it out, and that first week is really, really brutal. So I kind of felt like it was the same situation that I was feeling with Python, except here's what happened though. By the end of the week, I kind of started to get the hang of it, and in a weird way, I kind of became oddly obsessed with the language. So after that first week, that the struggles learning the language, and I think it just being new to me, to then quickly seeing, okay, it's kind of focused on stats. These are the things I need to learn. I need to learn to work with data. I need to learn to visualize. So weeks 2, 3, 4, and on into the future, I just became obsessed with the language. I was really enjoying it. Around that time, there was a lot of innovation coming from the R programming language. There still is. And the main suite of tools, which was data wrangling, is called the Tidyverse now. So they had just came out with dplyr when I was learning, and so on. So it was really cool. So now I transition in this phase where I'm now going to set out to learn R. And from my background, it definitely resonated with me. I began to use it pretty much for everything. I actively tried not to use Excel. So how did I go about learning it? Around that time, MOOCs became really popular. So there were all of these different companies that were starting out, and they were just offering, courses that were, available to us. So I started taking those. I also was Googling and using Stack Overflow. Those were super helpful. And then really what also helped too is I began writing about what I was doing. So this is an example of one of my first articles that I still actually have on business science. It's called Quantitative Stock Analysis Tutorial, screening the returns for every S&P 500 stock in less than 5 minutes. And this was something that I was like super pumped about because finance was my hobby. I was using R also to not only for work, but for managing my own financial portfolios and that sort of thing. So it was really cool. I did actually purchase a course. So I invested $450 at the time, which I felt, was a good value in the Johns Hopkins data science course, because it was going to teach me over several modules, how to use our programming language from a data scientist, and it was really cool. It was very exciting. However, I will say this: I almost quit several times, and the thing that really accelerated me was not necessarily taking the course, but fundamentally, I saw kind of what the course. There were several issues that I had with it, that it wasn't it was done by like a biology person, and all of the examples in there weren't really business related. But I really, as I got kind of towards the end of it, I got this really kind of interesting idea. So I had been using R for financial analysis at that point in time a ton. And a new suite of tools were coming out, this dplyr package and also this ggplot2 package. So for dplyr is for data wrangling, and then ggplot2 is for data visualization. However, none of it worked with the R finance packages that I was using in that ecosystem. So one of the packages that's in the R finance ecosystem is called QuantMod. They all use this package called XTS, which is like a matrix. So without diving into the ins and outs, the main difference is QuantMod uses XTS and dplyr uses a data frame, which is kind of like a spreadsheet table. So I wanted to be able to do everything with dplyr that I was doing on the finance end. So I got this idea. What if I made an R package that made it easier to integrate finance with data frames? And this is what caused me to almost quit that $450 investment. I was this close to the end, going to get the certificate, and I almost stopped because I got this idea, and it was like the light bulb went off. And when that happened, this is really what took my my data science and me learning how to me learning the R programming language. It's what it really accelerated it exponentially. So to fast forward, the things that I learned just in doing this project, which was building this package called TidyQuant, this package, I had to come up with an idea, which it was going to integrate both the XTS and the dplyr and allow everything to come in as dplyr and exit as dplyr. And then under the hood, it was going to manage all the XTS stuff for me. So I had to learn a ton of stuff. I had to learn, XTS and dplyr inside and out. I had to learn functional programming. I had to learn how to make R packages and how to distribute them. Plus, I had to learn, how to do a whole lot of iteration, because that's really where the value comes in using this TidyQuant package, is to be able to scale up my analysis from just using one stock to like all 500 stocks in the S&P 500. And so I learned a ton through this project. And that's really what kind of transitioned me into building business science. And here's why. So that TidyQuant package, I ended up releasing it. And after I released it, it just kind of what shocked me, it became very, very popular very quickly. Because apparently it solved a big need that not only I was having, which was being able to manage, kind of this workflow with data frames, but not have to convert to the XTS all the time. Other people were having the same problem. And they ended up, so I just took this snapshot. It's as of now, it's been downloaded almost 500,000 times. And it's just kind of been wildly successful. And with that success, while I don't make any money off of the software, and I never intended to, this is something that I'm very excited about, is contributing to open source. But I started getting consulting requests, and this was exciting. So this is how I kind of transitioned from, being this kind of coder who built this R package that became successful. It was good, it was good publicity at the time. So I actually received a big opportunity with a Fortune 500 company about a few months after I started getting into consulting, and I felt really excited. So, kind of like this baby in this picture, this was me. When I get this kind of a company that does 8 billion a year in revenue, and they were reaching out to me to help them out with their analytics department, and it was related to an HR assignment. So me being super excited, I took that job, and I really set out. Sky was the limit, or so I thought. So the way the engagement went, it didn't exactly go how I wanted. So I've been working with this company, kind of going back and forth, and what they wanted was to provide some analytics as part of a presentation that they were getting ready to present to their board on the HR side of things. So we spent all this time kind of working on the contract and this and that. And then we ended up eating in so much time that I ended up getting the data on a Friday, and their presentation was due next week, which meant that I had to have a report to them on Monday. So by the time it took me to get all the sign-offs and everything, I received the data on Friday. I actually hired a consultant in the HR space to help me out with it, because he knew more about the HR end of it and I knew more about the data analytics. So I figured if we joined forces, we'd have the best opportunity for success. So we worked nonstop on it over the weekend. We made an awesome report showing actionable insights, and we were super excited about it. We presented it on Monday, and after I presented it to the HR team, there was nothing. It was very silent, like this. So what ended up happening, and anyone in the consulting business or anyone that gives a presentation, you never want it to be silent after you're done speaking. You want there to be questions. You want there to be engagement, excitement, something. And there was nothing. So I knew we did not do a good job. And I never found out exactly what I did wrong, but they, let's just suffice to say, I never got a job with that company again. But it was a good learning experience. And, I was really upset with myself. So I kind of set back and I took a little bit of time, about a week or two. I stopped taking on any engagements, and I just kind of sat down and I said, hey, what if I was them in their shoes, what would I want to see from me knowing nothing about data science but wanting to integrate data science into my company? What would I want to see from a consultant, and what would help me better plan and better iron out some of the details up front? And the solution that came about was this thing that I called the business science problem framework. It was something that is more of a tactical and strategic tool, that really kind of walks through the process of kind of how I viewed that a business project should be kicked off, when to get stakeholders involved, what details to iron out up front. And it leveraged another tool, which is a very popular tool called Crisp DM. The Crisp DM framework's been out forever. The problem with that framework, though, is it's not detailed enough. So what this BSPF does is it dives into the details, like specifically what you need to do for the business units, what you need to do for setting up this project, what gates need to be open and shut, and when to shut them, and who, and how to think about a project. And also it integrates talk about KPIs, which is something that, it's not really covered in detail, like what KPIs to look for and that sort of thing. So I created this business science problem framework, and I began taking on engagements again. And I found that client success went through the roof. When they saw this business science problem framework, they got excited, because this is something that a data analytics team that knows nothing about R or Python at the time, or anything about, the machine learning, that was just a buzzword. And when they saw this is something that they could get behind, because they understood in plain language, English language, that they could, see where each part of the process kind of develops and how the project would progress through different stages. And the most important thing is they started valuing this kind of strategic approach. And because they valued it, I found that I could also increase my rates as a consultant. So I was excited about this too. So client success went up, and I can actually earn more money just by using this kind of project-based approach with a framework. Okay. So how did I get into education then? I'm talking a lot about, consulting and working with data science organizations. So the problem that I found when I was working with all of these companies is that the problem wasn't that they needed a consultant. The problem that they were trying to do was they didn't know how to bridge the gap between data science and the business. So they didn't know how to take their analytics team, get them the education that they needed in order to be able to basically look for insights that are actionable, that their company valued and could help improve results. So this was exactly what I was learning how to do through this trial and error approach with the company. And I found that when I was working with these organizations, that quite often they had the tools in place, they had people, they had good people in analytics positions that I was working with, but they just didn't kind of know how to connect the dots. So the problem is that educational programs, so the programs that are out there, the MOOCs, the biggest offenders are actually the educational institutions like the universities and colleges that are out there. They just don't teach you this. They focus so much on theory and the tools and machine learning, and this is what a linear regression does, and this is what deep learning is, and convolutional neural networks, and this and that. Those things are important, but what is also really important is being able to apply those things. And this is where I came in, because I was figuring out how to do this. I was excited because I was learning all of these different techniques. I was researching papers and finding different new tools that were constantly being released, and I was testing them through all of these projects. I was testing them through the company that I was working with at the time, the valve manufacturer. So what I ended up doing was I started by developing a program, and I ended up developing. It's now a 5-course system, but you'll see that it has, through my consulting and through my educational experience, I have the most important concepts and the most important strategies and the most important tools. And I also have the most important frameworks that I've learned through my years of now that I've accumulated of experience working with in consulting arrangements, working with businesses, managing a sales team, working just as part of an organization that needs to have analytics information provided to them so they can take action. And what I ended up doing was I started actually building a business off of that. So I launched my first course. I think that was in the middle of 2018, and it was actually this course here, and it's the one that I teach the business science problem framework, and I also teach automated machine learning in it. And it had a huge success, or at least for me. I had a bunch of people sign up for it, probably 100 or 200 within the first couple of months. And to me, that was super, super exciting. And I had a survey in there where they got to provide their feedback. And I actually met with many of the first students, and they really told me very candidly what they liked about it, what they didn't like about it. And that feedback was just super, super important. So I heard that they needed a community. That was one of the situations where they were having a tough time debugging an error. And what came out of that, a conversation with a student that was kind of really frustrated at that point in time, was the Slack channel. So I started adding in a Slack channel, and we decided that would be a good approach. And that Slack community has now grown to over 1,000 students. I mean, there's I think 1,200 students in that Slack community alone. And it ended up being one of the biggest single successes of the program, because now students have a way to get their questions answered and ask questions, anything ranging from, why am I getting this error, to what are you guys doing to deploy solutions? What are you doing to do this? So it really became a good tool for leveraging other students that were taking the course, as well as the instructor being me. I started finding out, that students, when I launched that first course, were struggling a little bit because it was more of an advanced course. I didn't start out with a basic course. And that's where I got the idea for the 101 course, which is where I teach kind of the foundational tools. And that ended up being a massive success as well, because many of the students that were struggling with the more advanced course that taught the business science framework were then going backwards and taking the 101 in order to get their skills. And this is where they learned how to do things like data cleaning and visualization, some of the basic tools that I thought, I just assumed people would know if they were taking the 201 course, which was totally not the case. And And then that's pretty much how I got the idea of how to build this entire system, was by asking questions and trying to figure out what students were, what problems they were having, and what they were really interested in learning. So one of those, one of the key things that I actually started doing a lot more towards the end of my consulting journey was doing web apps. And this was really important because what they were finding is that they would make these data science projects, but then they didn't know how to distribute them throughout their organization. So one way that you can do it is by building an application that serves these models to your end customer, which is going to be like somebody else in your organization typically, that is not a data scientist. So it might be your marketing team.
Matt, could I just jump straight in
Sure.
with some questions if I can? And thank you so much for your presentation
Yes, yes,
so
yes.
far. I think the business science problem framework is a fantastic tool to use for people, and even just doing the course in itself is well worth that. Tell us a little bit about the demand in courses now and how that's pivoted over the last 6 to 12 months.
So the demand over the last 12 months has been surprisingly strong, with everything that's going on out there in the world, with COVID and everything that's been changing the face of the world as we know it. The changing trends that I'm seeing right now is I'm getting a lot more into how do I take this model into production. It's how do I distribute it? How do I work effectively as a team? How do I integrate my unique skill set, which might be R, into a Python team, that has a lot of members on Python. So we're finding that student demand. I think we're up to over we're almost at 2,000 students now. The demand last year was really strong for people that were interested in this program, but I see that the tools are constantly changing, and the challenges that organizations face, some of them are still the same, like connecting data science with the business. They're still having a tough time doing that. But the problems are growing because there's so many different competing technologies out there, like AWS, Google Cloud Platform, the Microsoft Azure as well. And how do I leverage the immense tool set that they have in there, being like, how do I do machine learning models? How do I create things that are APIs, which are ways to communicate your data science to other different programs like Excel or Tableau. So that's kind of how things are shaping up. The trends are growing more in the cloud. They're growing more to how do I leverage kind of my tools and build something that another product or another group in my company can connect up to. And it's really cool. It's actually it's really neat, but it's also a big change from kind of the traditional of, hey, just make a PDF report and send it to my boss.
Matt, tell me about the roles of APIs and R and Python.
So there's the big thing is that no matter what you learn, R or Python, chances are your end user is going to need is not going to be an R user or a Python user. So they're going to have some format to ingest that information that you want to give to them. And the key is an API. So if you've never heard of an API before, all it is just, it's something that lives on in the cloud or on a server that somebody else in your company or even a client or customer will be able to authenticate and be able to connect to. So that allows them to connect up to your program. Their program can send a request and they can get a response. So for a machine learning or a data science example, say that they're, wanting to know what a sales forecast is for the next 6 months for a product. The app on their end might be Excel, and they may, have like a field in Excel where they update and say, I want this product code. And then that'll send a request to the API. behind the scenes, on a different server somewhere in the cloud. Something runs, it spits out a response. This is the next 6 months of sales data for that product, is what the estimate is. And that goes right into their Excel file. So that is becoming huge. Also, applications, being able to build, apps using technologies like Shiny, um, being able to use technologies like the new ones on Python are Dash and Streamlit. Those are very popular as well. But the APIs is, I think, really pretty interesting, because that's what allows other technologies like Tableau, Power BI, some of the BI tools, ClickSense, those to connect up to it.
Matt Dancho, CEO of Business Science, thank you so much for your time today. Really, really appreciate it. We're now going to pass on to Guglielmo, and he's going to give us a presentation. Thank you again, Matt.
Thanks so much for having me, Mark. It was a pleasure, and I hope you enjoyed the presentation.
And our next guest is Guglielmo Iozzia. And Guglielmo is the Associate Director of Business Tech Analysis at Merck. And today he's going to give us a presentation on real-life computer vision systems from Academy to the Wild. Guglielmo, fantastic to have you on the virtual meetup today.
Thank you, Mark.
Over to you.
Thank you, first of all, Mark, for inviting to this event. So, well, you already introduced me, so I will be pretty fast on this. Just give a little bit of context on where I work, because that's part also of the presentation I'm going to do today. So basically, at the moment, within MSD, which is a Merck for people coming from North America, I'm a part of the manufacturing division, IT, and in particular, I'm focusing on machine learning AI system, try to understand if there are business cases where this could be applied, and deliver the ideas to production in order to generate business value. So that's what I work on. I'm at the moment mostly working on computer vision, but not restricted to this field. So that's where I specialize so far within that big umbrella, which is machine learning AI. 2020 has been a very prolific year in terms of released research papers, in particular for computer vision and natural language processing. If we just narrow the scope to the December conference, that the NeoRIPS 2020, there were plenty of interesting research paper about computer vision. I just put here some of those that are of my interest from that conference, and that I start to dig into, but there are many others, so this is just a sample. In the past years with my team, often we try to get some research paper and try to reproduce them to understand if that could be some potential fit or something to add to our project. And we faced a lot of challenges. So basically, our understanding was that while, and the impression I had from this conference and other that I attended during the 2020, so the focus of research is mostly on algorithms, models, how to optimize them, and so on. But when it comes to reproducibility, or try to use these things applied to real life project, that's a challenge. So just to mention a very simple example, most of this paper are also available or would be available into papers with code. I'm pretty sure you're familiar with this website, where basically you have the paper and some associated code or other files that should allow you to reproduce the exact same, but that's not the case. So in many cases, we just struggle, me and my team, to put these things up and running. So just before validating them. So this is a real challenge, and this is a problem when you try to do things in a production environment, because there are a lot of challenges that unfortunately are not part of many college university program. And today I'm going to give an overview of what's the real world for computer vision, but in general for machine learning AI. What's the difference between theory and reality? 2020, unfortunately, has been would be remembered not just for having a bunch of research paper on machine learning AI, but also because the COVID-19 pandemic started. So finally, we start to see some light. There are the first vaccines, several vaccines approved for this. Now the next step will be to roll out the vaccine to have full coverage of all the people in our planet. So I would like to use this specific use case in general for vaccines as an example of a real world project, and what are the challenge from a machine learning AI perspective. So for in general, for any vaccine, once you completed the drug discovery part, and then you pass across different clinical tests to assess that that vaccine is really the right fit for a particular virus or other disease. Then the next challenge is to produce it at scale, and then of course move it on the other steps of the supply chain to reach as much patients as possible. So as part of this process in manufacturing, I want just to focus on a specific phase, which is the quality inspection. And in this slide, I try to compress the typical day. You see a question mark there. You will discover in a couple of minutes why there is a question mark in the life of a quality inspection engineer. So for example, for vaccines, but in general for other biopharmaceutical products, once batch is completed, all of the products, if they are vials, ampoules, the associated syringes, whatever, pass through some inspection machine from different vendors. And this machine basically assess the quality of the product, to say this could pass, could move on in the supply chain, or need to be discarded. And this work is supervised by quality inspection engineer, which typically is not just for biotech, but in general in different manufacturing. It's the same. Most part of this work is still manual. So this machine generate data in a form of images or other metadata. They are not enough for quality inspection engineers to assess, to do their investigation, and to receive some recommendation or understand which action to take for that particular batch, particular line of product. And typically they need to integrate this data with data coming from other data sources. So this process is time consuming, is often manual, and after that is up to quality inspection engineers to cream this data together, produce the report, charts, and then start understanding if there are some insight from this transformed data, and if they could get some recommendation or understand about root causes for a particular rejection rate of some machine, and take action accordingly. So the flow is seems pretty straightforward, which is, but the moment someone asks you to understand if this could be improved by applying machine learning AI, that's the challenge. So typically people fresh from the college, data scientist, machine learning engineer, in this process tend to focus on the last mile, say, okay, I have to consider this data and start to think something that could provide recommendation, insight, or other proactive action for to help the engineers that, by the way, are kept into the loop. But there are several pitfalls on this. So if I In order to understand this, we have to introduce the concept of technical debt. So this is a concept that was born in software engineering, but really applies to machine learning, AI, and other technologies. This is around since 1992, introduced by Howard J. Cunningham. And you can see an analogy with the fiscal debt. So at the end, you have to repay it sooner or later. Otherwise, there could be consequences that could differ depending on the particular context we are dealing with. Typically, you accumulate debt anytime you don't spend time to produce quality code. By code here, I mean any context possibly where everything is treated as a code. And there are different ways to remediate, by remediate, I mean to repay the technical debt, depending on the specific context technology. But there are two concepts that are common to any context as well. So one is that repaying technical debt, this doesn't happen by adding new functionalities. In the best case scenario, there basically you will just adding new functionalities, but not, let's say, repaying any debt. In the worst case scenario, you are going to add extra technical debt on top of the existing one. And of course, the activity, any effort needed to repay technical debt is mostly to reduce error and improve maintainability. So this is, as you can see, is disconnected by adding new functionalities, features to the system. In the theory of the technical debt basically is pretty accurate, but doesn't provide, unfortunately, a clear definition of those metrics that you have to monitor to understand how to reduce the debt. But by the way, there is a solid principle here is that depending on your specific system, the awareness of what technical debt is in that particular context is a good start, because this way really could pave the way to understand what are the metrics remediation that you could take to solve this. Narrowing the scope to machine learning AI, there is this interesting paper from Google from 2015. I print this chart and attach to any office or any space where I worked so far since 2017, because this is the reality of a project. So basically, this paper, the goal of this paper was to highlight those areas in a machine learning AI system where there is the highest chance to accumulate technical debt. The size of the blocks in this diagram is important because the bigger the block, the higher the chance to accumulate technical debt. The outcome of this paper was that you can see there is the smallest black box in the middle, which is the part related to the machine learning code itself. So as you can see, most part of the technical debt is accumulated not there, but on the surrounding infrastructure. And how this fit in the example that I presented a few minutes ago. So if I translate the same, go back to the quality inspection scenario, you can see that all these things are there, all these risks are there. So I highlight them in red. So from experience, I know that unfortunately inspection machine belong to different vendors that still don't care about the software they equip their machine with. So it means that each one has his own standards, formats, etc. So the images collected by different inspection machine have different format, different resolution. Some of these machines, some vendors don't provide any direct facility to interface the machine to collect images and metadata. So there is extra work on top of this. And you have to think about the serving infrastructure to move this data in a safely and efficient manner. Also, the data collection should involve external data sources. Data verification and feature extraction is demanded to the quality inspection engineer only. So you can understand this is a very error-prone process, and people sometimes have different standards or different, it could be an opinionated feature extraction collection of data verification, same as for the analysis of the tools that a specific person uses. And of course, all these things would affect the quality of the machine learning, deep learning solution you will put in place for the specific computer vision matters, or in the worst case, preventing you to deliver something because you have really bad shape before jumping into the core topic. So this is the reality of a computer vision, but in general is the same for a machine learning AI project. So it's not just about algorithms and model this. But when jumping into new project, what are the key areas to focus on before moving to the core? So here I put some stats from this is from 2016, taken from Forbes, but it's still valid if you see the other the research results are the same today, even if now you have more tool and more and a better mindset on addressing these problems. As you can see, the part about refining algorithms is just 4% of the overall work. This is a worst case scenario, but there are situations where it's better. You could reach up to 5 or 6%, but that could improve. And basically, the key areas to focus on when starting a new initiative is, first of all, understand the domain. So try to get as much knowledge as possible on that domain. I'm just to give an example, I'm working now since 2 years for MSD, and in these 2 years I learned a lot about biotech manufacturing. So I came to the company bringing my skills, my expertise in machine learning, deep learning, but at the same time not only helping on implementing this solution and move them to production, but also I'm learning because it's important that I understand what are the real needs and challenges and issues there, and provide the right solution for that. So sometimes with some data science team, in particular with external data science team that don't have the proper domain knowledge in a particular context, they come with this great solution using the state of the art for machine learning AI, but not the right fit, not the right solution to solve that particular problem. So this is important, and start engaging a conversation with the stakeholders and users as well. Regulations. So that's another big matter, in particular for some industries such as healthcare or manufacturing, because they are subject to multiple regulation, and you cannot skip this when thinking about access to data or designing the solution. So that should be part of the design itself. Data access is a problem related to that one, but in particular for big corporation, on top of the existing industry regulation, there are several policies to grant access to data. So that's not granted for sure to everyone. And on top of this, there is another big problem that many organizations don't have in-house some solution to automatically provide anonymized data set to start the work. So this is something that should be assessed since the beginning, because otherwise you don't have any data at all. So you can think to do machine learning AI. Data scarcity is this is basically, data scarcity is not in terms of overall availability of data, because in almost every sector now there are plenty of diverse sources of data. So the data scarcity here is related to a specific event. Imagine, for example, in an event, some seasonalities for time series data, or some defect that happened for some product in manufacturing once or a couple of times a year. So you have a very big data set, but very few data for a particular event. So in this case, you have to understand this since the beginning, and working with stakeholders, and try to think about some proper strategy, such as data augmentation, one-shot or few-shot learning, synthetic data generation, whatever fits that particular issue. So this is something that, in particular, manufacturing is happens often. Data quality. So the real world is not Kaggle or the research world where you have already available data set that are with clean data, in particular for images and videos with high resolution, perfect pictures, etc. So unfortunately, I cannot show the images me and my teams deal with, but you will see that is a different matters that cats, dog, or cars, or the MNIST data set of the ImageNet. So it's a totally different scenario. So most part of the work in computer vision, it's around 40% of the time goes into pre-processing images and preparing them to be used for training, validation, any other purpose you have for your project. So this is the main difference between, I used to say Kaggle, or any other machine learning challenge or the research world itself. Infrastructure, so whatever is the size of your organization, if it's a startup or it's a big organization, a medium organization, there are still many that don't have a full IT maturity, and this reflects, of course, in terms of machine learning AI. So don't take for granted that before you start, you have all the tools, all the hardware, all the pipeline you need on that. So this you have to start this conversation as soon as possible, and also try to measure some sort of financial acumen on this, because at the same time you have to think about optimize the thing you're doing to optimize costs and avoid asking for tools or other resources that you probably wouldn't use at all. So I saw some situation where people ask for a lot of GPUs, and at the end it's probably a simple matter of standard machine learning that could be addressed by also machine with just CPUs or running in a distributed system that is already available there with Spark or other. So sometimes people tend to ask for resources that are overkill for a particular project. Reproducibility, that's key, because it's important that a successful machine learning AI project that can move to production is not just a Jupyter notebook or some model trained in a local laptop or in Colab, for example. So it's there are end-to-end workflow from the inception to production, including also the monitoring, to which you should always be able to replicate the same process and the same performance, whatever team is using that with the same data. There are plenty of solutions available to achieve this, so it's just a matter to find the right one for you, and also measure the mindset about reproducibility. Automation, of course, so it's automate as much as possible all the repetitive tasks in order to save time and minimize error, and also speed up the deployment to production. Once things are moved to production, people tend to believe it's done. No, it's done. That's just a start. So you have to monitor your models in production, because performances sooner or later will deteriorate. And also you want to understand how the models are behaving when they meet new data, and so you get information about if there is room for improvement, for retraining the models or other stuff, or fixing some things. So monitoring is another key area. And last but not least, communication. So this is a typical traditional business models don't fit properly if you want to apply machine learning AI. On top of this, if you add the hype which is generated by media, by the vendors or other people around these technologies, so often see that stakeholders have confused ideas about what machine learning AI is, and if or not could be the good fit to address a particular business problem or need. I saw some projects failing because the data scientists and machine learning engineers came up with the right solution for that particular need, but they weren't able to present or make the stakeholders, the business, in a condition to understand where the value would come from that. So it's common that to create a communication breakdown, it's important to tune your communication style depending on the audience you have, in particular if it's a non-technical audience. And finally, business value. There is only one way to understand if you really are getting the expected business value for your solution, which is moving to production. So that's if you follow all those practices and you make sure that that mindset, finally you will succeed to move good things to production. And that's the only way where you could show and also understand that you are realizing the particular business value. Otherwise, you have just some business problems or business need and a business solution, but not having business value. So there is no other way to assess this. Probably you're asking on top of this, is there something missing in this conversation? What about the algorithm themselves of the models? So that's a minor problem. So if you recall back the paper from Google, you see that once you have this full mindset and these best practices in place, then the part related to thinking about the best algorithm for your or model for your solution, how to train it, how to validate it. It's a walk in the park. So that's not the a big issue on the in this context when in the real life world. So that's why it's not part of this conversation. So that's the moment when you can pick up some research papers and start to understand if you could apply them, or starting from scratch your own personal research for that particular business problem that is the first time you are going to address. So I hope that after this conversation, the key takeaway is that when you start a new AI initiative, your first concern should be not algorithm and models, but data dependencies and infrastructure. Then that comes after. And that's all I have for today. And feel free to reach out also to this contacts if you need to hear more.
So thank you so much for that. There's a variety of questions I have there. We could have loads of time spent on them. I love what you said, that when you get into production, it's just the start, because so many people think, oh, I'm done. It's in production. But that's when you actually need to start monitoring them. And I also really like what you're talking about, being reproduced, because you have to be able to consistently reproduce them as well. But engaging with stakeholders, making sure that you're actually working on the right problem is so important, because we all know people who work on incredibly, do really, really good, but it's on the wrong problem, and they waste so much time perfecting the wrong problem as well. Tell me about some of the healthcare and the opportunities that we can go to the next level, because I think everybody in the world is interested in healthcare, because we're all, related to it. It all impacts us all the time, particularly in the world that we're in now.
Yeah, basically, I noticed that in 2020 there was this big trigger of the COVID-19 pandemic that shifted the interest of research corporations, also individuals, whatever, towards healthcare or towards the pharmaceutical. But to me, the greatest challenge that we have to solve is to understand, to apply machine learning AI for good. There are plenty of open questions of challenges that no one used to address before, but they were already there. So just for example, to stay in the case of this COVID-19 situation, this is something that should have been foreseen before. So it's, of course, it's a new virus, it's a new pattern, but the fact that some pandemic could start, they should have been foreseen years ago. And so I hope that people start to shift their perspective, saying, okay, I will try to apply this to solve real world problem, and not just applying things just to e-commerce, fashion, or other fancy things. Then, because the technology is there, now we are lucky that we have plenty of resources to learn things, plenty of tools and hardware resources to play with. If I go back in time when I got my master degree 21 years ago or more, I remember remember that we used to collect data manually for the bed of the patients. For that, used to build filters for those data in MATLAB, just manually coding or thinking or doing something in a whiteboard. Now all that work could be automated, and you could focus on the specific matter of that. So I hope people now focus more on the real problems rather than some fancy stuff.
Thank you very much, Guglielmo. You've been watching the AI in Action virtual meetup hosted by Alldus. I'd like to thank our guests today, Matt Dancho, CEO of Business Science, and Guglielmo, Associate Director at MSD. If you enjoyed today's virtual meetup, please give us a like and follow us or subscribe. And for more details, you can also check out www.aldus.com/podcast and also /community, where you'll find more insights from data science and machine learning as well. Take care. Thanks again.